Now we're going to skip number 5 and go to number 6. Now, number 6 is one we did in class on a warm-up, the rope swing problem. Zoe is at summer camp. One day she's swinging on a rope tied to a tree branch, going back and forth alternately over land and water. Nathan starts a stopwatch. At x equals 2 seconds, Zoe is at one end of her swing at a distance of y equals negative 23 feet from the riverbank. When x equals 5 seconds, she's at the other end of her swing at a distance y equals 17 feet from the riverbank. Assume that while she's swinging, y varies sinusoidally with x. So let's set this up. Let's draw our axis. Now we do have negative values here, so we're going to have a negative y, or negative values on the y-axis anyway. This is y. And let's call this x here. So obviously I'm going to have to move x up some to get a negative y value, but it works the same way. This is x. Now our maximum value is going to be 17 feet from the riverbank, so let's call this 17. And our minimum value is going to be negative 23 feet. Okay, now let's use this to find the amplitude. Amplitude is high minus low. So 17 minus a negative 3 becomes 17 plus 23 over 2. So this is 40. So the amplitude is 20. That's A, 20. The vertical shift is the high plus the low. So 17 plus negative 23 over 2 is going to be negative 6 divided by 2. So that's negative 3. So vertical shift is negative 3. That's D, negative 3. So let's draw D. That's the x-axis. This negative 3 here is going to be the adjusted x-axis, which is x prime. This is x prime. Now let's look at our times on this. So when x is 2, we're going to be, let's call this 2. So this is 2. And then at 5, 3, 4, 5. At 2, she's going to be at negative 23. And at 5, you'll be at positive 17. So in 3 seconds, she went from negative to positive. So in 3 more seconds, she'll be back to negative again. So now she's back down here. So this is 8. This is 11. So at 11, she's back up here. 12, 13. At 14, she's back down here. 15, 16, 17, she's back up here. That's our graph. Now since we're starting at 2, we're going to move the y-axis over to 2. That's going to be our phase shift. And this will be our y prime. This is y prime. So the phase shift in this case is 2. That's going to be C. The period is going to be the time to get back to this point here. So that's going to be 8 minus 2, which is 6. So B is 2 pi over 6, which is just pi over 3. So our graph is going to look like this. It's going to be sinusoidal, so make sure you don't do a straight line for this. And it'll continue. So it's going to look something like this. And it'll just continue in that fashion there. So we've got that. Let's get some key points. At 2, we're going to be at negative 23. And at 5, we're going to be at positive 17. Now if we look at our graph relative to this new, here we are here, this is our new origin here. It's not sine because it would start here if it were. This is negative cosine, so we're going to use this. So y equals negative a 20 cosine of b pi over 3 x minus 2 minus 3. Now if we look at this, our window on the y-axis has to go from negative 23 to 17, and on the x-axis, this is number 6, we need to go out past 13.2, so let's go out to 14 on the x. So we'll go from 2 to 15, okay, and y will go from negative 25 to positive 20. Let's put the equation in. Negative 20 cosine pi divided by 3 x minus 2 minus 3, and graph it. Well, that looks like a reasonable expectation. Let's check our key points. Second trace 1, put in 2, we get negative 23, which is good. Put in 5, we get 17, that's good. And now we're asked, find y when x is 13.2. So we put in 13.2, and we see that y is negative 16.38. That is problem number 6.